Hey everybody, this is Larry, this is Amigo with Q2 of the weekly contest 464, partition array into K distinct groups. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. I think this one is a very poorly written problem. I don't know if they have proofreaders or not. I assume they do, but they did collectively did a poor job writing and a poor job proofreading. The reason is because I spent about 10, maybe 15, maybe even longer, I don't even know. You could watch the tape on this problem just because I did not know what the definition of exactly K distinct elements. Exactly K distinct elements does not imply that they're K elements that are distinct, right? Yeah, I don't know. Maybe you could argue that you can, but the point is that if someone can make a reasonable case that you can argue, then it doesn't have to be wrong for everybody. It just have to be wrong for enough people. And I think this one is very poorly written. As a result, I just took a long time because I was like, some part of it I would also say is maybe it is my lack of practice, right? Meaning that I think the other way of doing it maybe is NP. I don't know. But if that was the case and I knew that was NP, then I would have not tried to do it because it's not possible. But nonetheless, once you realize it is a much sillier problem, which makes this kind of sad, if you ask me, because I took a while. This one for me. But yeah, but overall, not that bad once you realize it. I think the key thing to note is just try to figure out what the impossible cases are. I think for me that's a little bit easier. Keep in mind that for this problem you do not need to construct the groupings. Though I think I think you could just do it greedy, like just go one by one. You can surely do that. The only thing is that because you have n numbers, you have k elements or k distinct elements in each group. That means that groups is just n divided by k. And then if the max of these, that means if any number appear more than k times, then you cannot do it, right? Hopefully that makes sense. And obviously if n is not a multiple of k, you also can't do it because you just don't have even number of groups to have k elements even. They don't have to even be distinct, you just don't have enough k elements or it doesn't go into it. Otherwise, every way you can just, like go with line by line, group by group, and spread them out. And and it should be true. This fact you should, I wouldn't say you should know it necessarily, but it does come up in more difficult problems. Not necessarily in a way that, you have to implement it, but knowing this idea will allow you to be like, oh, I know this is true, so I can now build other things based on that, build other assumptions. So that's basically what I would say about this. Overall, not an interesting problem, except for the fact that they miswrote it poorly, so I don't know. The way that I did it is with linear time, linear space, because I just did a counter. You can maybe do a little bit differently with sorting and then just counting the number of distinct things if you really want to go that way, but I don't know. Well, I mean, you're just talking about complexity trade-offs, because then, but I don't know. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me struggle during the contest, confused about this problem, next. For contest, we could do that later. Alright, partition array in the k distinct groups. Nums k, all elements of nums in the one or more groups such that there are k distinct. Each group has k distinct elements. Each element true. Okay. Each element in none. Okay, yeah. Each group contains exactly k distinct elements. So what does dupes mean in this case? I mean, you have this, but then there's also the case where if you have just an extra number, then it could be 2, 2, and then whatever, right? So what does this mean? What does this mean? And n is pretty big. K is pretty big, nothing crazy. What does this mean? That's what this question is about, right? The implementation is probably pretty straightforward. What does this mean? Do we sort? How do we treat the dupes? I mean, that's the problem that I'm trying to figure out. Because then yeah, here for example, if you do a set, there's 3 distinct ones with 4 numbers, right? Is it just greedy? Well, maybe. I mean, with this much, I mean, it is, but you have to do it in a smarter way. I think greedy is fine, but yeah, and you have to be a little bit smart about the greedy because you can't just go like 3-5 and then you're stuck with 2-2 and then you can't really have unique things, right? Oh, I guess the key thing is just that for distinct numbers, yeah. I guess, is it a min-max problem? Why am I so bad at this? This feels like for a Q2, I should have a more intuition about it. Am I looking for true or false? Maybe I'm looking for false. False, because I was looking for a true result, and trying to find the exact group, but maybe we can just find a false result. What is an impossible result? What does distinct number of elements give us? Okay, so if set of length of set of nums with length of this mod k is equal to 0, then we're good, right? If n mod k is equal to 0, I guess that's not technically true because they could all just have all the same number, for example, and then but this will be true. So then now I don't know. What makes it false then? Do I come back to this one? Okay, what is the answer if k is equal to 1? If k is equal to 1, then it is basically just this and that's it. What if the answer is 2? 2? Two is either this or I don't know. I don't know this one. This feels like a maybe there's a very simple solution, but I don't know that I have an idea about it. Because you have to figure out. Do you try for the number of groups? Binary search of the number of groups, maybe? How would that work? I don't know. I feel like this one's tricky. Let me skip it a little bit. Maybe I'll come back to it. Maybe it's not that bad and I just can't figure it out. So the number of accepted is way lower on Q2A, so okay, maybe not. Maybe because so many people get accepted. I'm cheating a little bit, but sorting doesn't do anything. The elements don't do anything in relation to the number of sorting. It feels like a binary search in the number of groups, but that doesn't feel right. So, okay, so 1 group is no good, 2 groups is good, 3 group is no good, right? So how would that work? I think that works that way. Do we try every possible group? Is there like a sliding thing? 1 group is all of them, 2 group, and then 3 groups, how would you even break it up? I mean, it's not possible, so. think I'm missing something very obvious. Do I draw it out? Huh. I mean, it's all about the distinct number, the things. So what does that mean? And is it, do we have a function on the number of things? Okay, so the number of unique things, does that set the number of groups? Not necessarily. Huh. Why am I so bad today? Huh. Wasting too much time on Q2. I don't have time for the other ones, but and we don't always want to split them either, so that's the tricky part, right? Did I misread this one? Each group exactly K distinct. I mean, that's it. No, I don't think I misread it, but I'm not getting it. I'm not seeing it at all. Because we can also have, if you have another number, then the distinct doesn't matter, right? Which is what this does. How do you say this is good though? This feels like one of those forms where I could get it, but it would take like 5 wrong answers. But is there a pigeonhole? Maybe there is a pigeonhole. Because we want K distinctive. So that means that, what does K distinctive mean? It's probably a pigeonhole, okay. Because if we have enough 2s, then we can always do it. Right, for example, like if K is equal to 3, no, I mean, well, K equals to 2, then we have enough 2s, but if K is equal to 3, what does that mean for this one? Well, this means that by default this happens, but what if K is equal to 4, then no, then, I mean, yeah, I mean, it's definitely forced that, that if length of f is less than k, and just return false. But then how do you get this one? What is the rule for this? If we have enough, if we have 2 extra numbers, would that be good enough? I mean, yes, but, well, no, not always, right? Because you could have 1, 5, 2, 2, 3, 3, or 2, 2. Then in this case, there's still no way, right? Because of the pigeonhole, because because by that pigeonhole, 2 of the 2's will have to be in the same one. I think I did do a for loop on the groups, but I'm not quite sure how to do it. Yeah, I don't know how to do it. Okay. Ooh, 33 minutes left. 6-point problem. Let's look at Q2 again. I don't K distinct. I don't know exactly K distinct elements. It's very weird. Do they mean like K elements that are distinct? Maybe that's easier. What would that say? K elements that are distinct. If it's K elements that are distinct, then what does that look like? So meaning that there are no dupes in the same group. I wish they have a thing where they show it. Well, it's still true that, well, if n mod k, I'm just going to YOLO guess on this actually. I mean, this is still true if you don't have, you know, otherwise groups is equal to n divided by k, right? And then how do you separate them out? Yeah, I mean, okay, there is the other thing of just this. I think that's it though, right? Like if this is the case, then if max of f dot values is greater than groups, then we return false. Then otherwise you can just you don't need to construct it explicitly, right? Is that the thing? True. I forgot that I could turn this on to this thing. I should have done it for Q3. True. Okay. Wow, that is a really poor problem. Problem setting. That's like a very ambiguous problem. That's really bad, actually. Okay, so we have half an hour. Can I get this? How does the ranking look? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about each problem, this contest, everything in between. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye-bye.